All right, this is for my Calculus 1 class. It's our inflection points and curve sketching lab and our extreme values unit. And I'm going to do a video for each one of these, and I'm going to show you how I want you to set this up. So first of all, we're going to sketch the graphs, find all the y-intercepts, critical points, inflection points, maxes and mins, and vertical and horizontal asymptotes. So the first thing is on the right here, I want you to draw a nice size sketch of the graph, and I actually graphed this so you can look at it. So here's my X and Y, and I graphed it on my graphing calculator, so it's right here. This is what the graph looks like. So let me move this down a little bit. So it comes down like this, has a little flat part, comes down. So I'm going to do a nice sketch, the best I can do with this. So I'm going to do this in red here, so I'm going to kind of draw. It's not perfect, but it kind of looks like that. And I want you to set up your F prime bar. Remember, this is your first derivative, and your F double prime bar, so set all this up, okay? And underneath this, before we do any of this work, we are going to set up everything we're going to do. We're going to find critical points, okay? And this is how it'll be like on a quiz. I'll have it set up for you. Inflection points, okay? And then we're going to have the y-intercept. And if there's a horizontal asymptote, we'll call that HA, and a vertical asymptote, which we'll call VA. Now, first of all, let's do the easy stuff, or the stuff that's quick. This is a polynomial. As you can see, it's a continuous function, and it's to the fourth power, so it's even, so my tails are the same. First of all, if we do the y-intercept, to find the y-intercept, all you have to do is when you do the y-intercept is you can actually graph it, and I know the y-intercept is 0, a number, and if I plug a 0 in my original graph, I'm going to get 6, okay? So my y-intercept is 0, 6. That's easy. You don't need to show me doing that because you can look at the graphing calculator. Again, because this is a polynomial, and you look at it, it's not a rational function, there is no horizontal asymptote, none, and there's no vertical, okay? Now remember, with the horizontal asymptote, there were 3 rules, and we'll be using those as we go along. You have to remember that. And the vertical asymptote, you're going to put your denominator equal to 0, and there isn't a denominator because it's not a rational function. So those are the quick things we kind of got out of the way. So first thing is, finding critical points. Well, our critical points are when we take our first derivative and we're going to put it equal to 0. So this is an easy one because it's all power rule, and it's going to be 12x cubed minus 12x squared plus 0 equals 0. So I put it equal to 0. Then we're going to factor. So I'm going to take a 12x squared out. So I have x minus 1. And then I'm going to factor that. It's not factor, but put it equal to 0. So I have 12x squared equals 0. Divide by 12. X squared equals 0. Let's take the square root. Basically, x equals 0. So there's one of them. Then we're going to do x minus 1 equals 0. So x equals 1. So I now know my critical values. I want the actual point. So when I plug a 0 in here, I get a 6, which is what we found out to be our actually y-intercept. And when I plug a 1 in there, I get a 5. Okay? So I'm going to put these here as my critical points of 0, 6, and 1, 5. Now I'm going to come over here. I'm going to use red for this, or let's use a different color. Use purple. And I'm going to put a 0 here and a 1. Okay? Now, what you need to do, now I've showed other ways, but you can take this factored form right here and go to the left and right, because basically this is a number line and I want to know what my slopes are doing or what my values are. And if I put anything left of 0, so if this was a negative in here and a negative here, I'd have a positive times a negative. So this is negative. Between 0 and 1, let's pick a half. If I put a half in here, this would be negative. That's be positive. Again, that'd still be negative here. If I pick something greater than 1, if I plug a 2 in here, this is going to be positive and positive. And so I have positive values here. Now, if you don't like this, you can actually graph just this in my calculator, which is my first derivative, and then graph that and just look at the signs on your table and say, okay, what are the signs doing? This means my original function is decreasing, and it's still decreasing here, and it's increasing here. So actually, I shouldn't have written that second decreasing because it kind of makes it look messy, but it's decreasing here, it's decreasing here as well, and it's increasing here. So if I look at my graph, that's what my graph looks like. It's decreasing and decreasing and increasing. So it justifies what we're finding with our calculus. Now, the next thing I want you to do, and I shouldn't have done this because I need all the room I can get when I'm writing on here, so I'm going to kind of erase that a little bit, fix that up a little bit, let's fix that. Okay, so this is decreasing. Let me do that again. This is decreasing, it's decreasing and increasing. Now, I need to have you do the first derivative test to see if there's any local maxes and mins. So if I go from here to here, it's decreasing and decreasing. But from this part right here, and this one I'm going to do in blue, I'm decreasing from here to increasing. So right here, this is a local min right here at 1. So I'm going to come here and say 1, 5 is a local minimum. I'll call it local min. So we labeled it. So we got our critical points done. You really need to make sure that you do this first derivative test here so I can see that you actually looked at it, and that's a quick way to do that part. Now let's do the second derivative. So I'm going to do f double prime of x, and I'm going to come back up here and do that. So when I get that, I get 36 x squared minus 24x equals 0. Because I got to put for my inflection points, I'm going to factor 12x out, and when I do, I get 3x minus 2 equals 0. Now I'm going to put all the parts equal to 0, so I have 12x equals 0. X is 0, so there's my inflection point x value. I have 3x minus 2 equals 0. 3x equals 2. X equals 2/3. So there's the x value of my inflection point. Now again, 0 is going to be 0.6. We've done that several times. So here's my 0 here, and the other one is 2/3, and 2/3 I'll put right here, okay? And for the 2/3, when I plug that in my calculator, I get a beautiful number of 2/3, comma, and I did a few decimal places, 5.40741. So there is my inflection points. So my inflection points are 0, 6, and 2/3, 5.40741. Now I want you to come up here, and actually now you can use your second derivative. So I'm going to kind of box this off right here. I'm going to look at this to do my actual plus and minuses. So I look here. If I go to the left of 0 and put negative in here, this would be negative, and this would be positive. So this is going to be, this would be, if I put a -1 in here, that'd be negative and a negative. So this would be positive. Sorry about this. So this is going to be concave up here. And we're going to look at the graph in a minute, and you'll see how it justifies. Then I tried 1/3 in between here. When I put 1/3 in here, this is negative times positive. So it's negative here. So it's concave down there. And then I did something greater than 2/3. So let's pick 3. It doesn't matter. So this is positive times a positive. So this is positive. So again, this is concave up. So if you look at your graph, it does my graph's not perfect, but it's concave, it's concave up here. Looks like it's maybe in here, it's concave down. Let's look at the original graph. So here's the actual graph. It's concave up. It does look like a little spot here where it's concave down, then it's concave up. So I hope that helps you. I'm going to do a video of each one of these. And so I want to make sure that you're comfortable with this. So here is exactly how I want you to do each problem. So I think there's 7 on here. So I'm going to do 7 videos. Here's the first one. And I hope it helps.